oligosaccharides. Sometimes in the books they will put oligo also in a classification of polysaccharides. So they say mono, di, and polysaccharide. But now also we can classify it into oligosaccharide. If we have 3 to 10 carbon chain, example like dextrine, is example of oligosaccharide. More than 10 is called a polysaccharide. More than 10 carbon chain together is called polysaccharide. Like starch, which is very complex form of the carbohydrate, has more than 10 carbon chain. This is a structure of the monosaccharide and disaccharide. أنا بدي شلون أبغى أدخلها just illustration أبغى شلون كيف أطلع. mono تنحيك chainy carbon هنا، while di bond من أمدوانا bond كبي أو شيء like acidic bond يكمل جو. do carbon chain كي يبي كبي disaccharide. وهذا dextrine سير وده carbon chain polyش لدزنته، أوكي؟ طبعا هنجار أوليغو أتواني أكثر classification polysaccharide. يعني أتوانين carbohydrate ده مش يبقى monosaccharide, disaccharide and polysaccharide. هنكتب شغلنا آخر mono, di, oligo and then polysaccharide. يعني همو حوالي خمسة. Now, regarding the stage 1 of the carbohydrate metabolism, we will talk about digestion and absorption. Let's start with this again, شلون بنقول ده اسمه نحكي وشلون digestion أو شلون أشوف circulation. Okay, so the digestion begins in the oral cavity by salivary amylase. طبعا كانت الكبسولة لازم تبدا تشيليني فارنكت بفيلتها وتزود ده شيء بس تمشي أم إنزيم لك أنا سلايفايا هي أو ترى salivary amylase. It continues in duodenum by pancreatic amylase. And the duodenum is the stomach man. I have each digestion of stomach regarding the carbohydrate metabolism. Regarding carbohydrate or food, each digestion of stomach each period time here. No, yes, that's why we skipped the stomach. Instead, the acidity of the stomach will kill the salivary amylase, will deactivate this enzyme. So no digestion will happen inside the stomach. We will go directly to the duodenum. In the duodenum, we have another amylase, but this is called a pancreatic amylase because it will be secreted by the pancreas. And the cell diagram and finally, completes in duodenum and jejunum by the maltase, lactase, isomaltase, and others. This is called a disaccharidases. The next slide will clarify this now. Dietary fiber cannot be digested by human enzyme in the intestine. We don't have an enzyme to digest the fiber, that's why fibers will pass undigested in the carbohydrate metabolism. Okay? So this is how it will begin. We have, if we eat a high carbohydrate meal, most of our meal is composed of a complex carbohydrate. It's composed of starch mainly, and some sucrose and some lactose from some dairy product like milk, yogurt, and others. So most of them are starch, and we know that, yes. So we have high carbohydrate meal. High carbohydrate meal زوربيت شيا زوربيت starch. Starch is the kind polysaccharide. It should be break into monosaccharide. The monosaccharide each carbohydrate absorption now. Starch it will be breaking become monosaccharide. As amino acid one, but she will die absorption rate. Protein whatever diet peptide absorption rate. طبعا نحكي carbohydrate في بيستوي لا polysaccharide ولا ده بشي كده monosaccharide. وطبعا يكون digestion process occur saliva by enzyme salivary amylase. Salivary amylase شيئات أم starch هني يكون شيء poly أكبر شو كتير polysaccharide شيء oligosaccharide. يعني تعطي polysaccharide break it randomly into a compound that's called a dextrine. Dextrine شيء اسمه oligosaccharide. عشان شيء هنا سير وده شيء هنا. يعني شو كتير polysaccharide. إذا مرحلين كي باش نعمل كل ما بدextrine هذا النوع ستوماتول مع الستومات يشتغل معنا digestion معنا أشبه duodenum. الduodenum شو معناه؟ pancreatic amylase. زي pancreatic amylase شو dextrine. Pancreatic amylase will break dextrine into maltose, isomaltose, sucrose, and lactose. Anyone knows what type of the carbohydrate are these? They are disaccharides. Imagine polymarket, but oligosaccharide. Next command disaccharide. Why are she can the breaking the monosaccharide in order to be absorbed in the small intestine? what's called a brush border disaccharidases. You see this ASES, this means an enzyme that will break the disaccharide. Okay? It will secrete from the brush border of the small intestine. هاي لما دايساكرايديز كويدة، ولا منها مالتوز مالتيزية، ايزومالتيزية، okay? سكروز سكريزية. ASE لقلت هاي هالشيء معناها this is an enzyme, okay? لاكتوز لاكتيزية، بريكيا كابوتشي بومونوساكرايد. فانت brush with disaccharides, it will break the further these disaccharides into a monosaccharide. They are ready to be absorbed. Majority are glucose. Some of them are galactose and fructose. Okay? So now they are ready to be absorbed in the small intestine. That is the small intestine. Has their way chipka, absorption or now circulation. Maltose و maltase بدو glucose, isomaltose و isomaltase بدو glucose, sucrose و sucrase و fructose plus glucose, lactose plus lactase و galactose and glucose. لو أنا هم ساكن باشا أجد maltose و isomaltase بدو glucose ده فقط شيء. هيك specific here ولا. Yes.
The glycosidic form.
What?
The
Yeah, how? I'm trying to achieve this now, any idea? سيدي glucose alpha 1,4 glucose يعني كربون نمبر 1 ما بس مالتوز باشا glucose alpha 1,4 يعني كربوني تشيني يكم بس راوة بشوارم كربوني تشيني دوما. اوكي glucose alpha 1,4 glucose يعني تشيني كربوني يكم لتشيني يكم بس راوة بكربوني شوارم لتشيني دوما. وعني شو تشيني بكربون تشين so glucose alpha 1,4 glucose أو مالتوز. While isomaltose you have glucose alpha 1,6 glucose. So meaning that the first carbon in the first chain is connected to the 6th carbon in the second chain. تجيشتن يعني أم glucose alpha 1,4 أم glucose alpha 1,6. أني كانت في شاطر glucose بس أول كنا شيء بيني glycosidic one كان أم بيرو شوارع أم يبوش نشان. تجيشتن فهذا أمام جيشتن أوي كمو بglucose وglucose fructose. Now it's ready to be absorbed. Try absorption a bit by healthy sodium. This is called a sodium glucose importer. طبعا قلنا أنا عن تفاصيل أكيد شلونية لبروي كلاكة مطلوب ميلتها. هاشتك ولا تفاصيل قلنا أنا سوي خطأ inflammation مطلوب ميلت. طبعا هتشون البيت ليه الصوديوم يعمل تيار. إما جلوكوز اللي زور معناه لأنه لومين small intestine حاضر بوي absorption البيت. لا مش بقدر صوديوم يتناول من الكوا بالمقابل جلوكوز أتشتناول سلكوا. تيجان imagine عملوا من كده هم جلوكوزا لأنه cell membrane brush border شاشي معناه صوديوم معناه صوديوم يتناول بإنرجي أو جلوكوز سكرتوا بوناو سلكاني كه هي brush border small intestine أوكي وين السلكان أو شتناو كوا شتناو circulation أو شتناو blood إذا حاضر بس أورجانيك أنا داوش أوكي anyone has any problem with this slide؟ But that's not the digestion. Okay, this is regarding the carbohydrate digestion and how we reach this part that's called glucose, galactose, and fructose. We said they should be in monoform in order to be absorbed. Later on, that it does not secure finally أشنا bloodstream. And bloodstream basically, then how they will be absorbed. It's carried out from the gut to the absorbed cell by active transport that's called a sodium glucose transport. Sodium will come down to the lumen and glucose will go up to the cell in order to enter into the circulation. From the absorbed cells to other cells by facilitated diffusion which need glucose transporter. ليه هو كان absorbed cell كان وشنا ناو circulation هوا إنجا شو بس الأورجانيك كان بعشرة شو همو أورجانيك كان كزاني BBC هو كاربوهيدرات جرجع. أو source energy به أو storage به لريش شو شتنا organic شتنا liver لريش شو شتنا brain لريش تبغى بيعمل glucose transporter from 1 to 5 okay أو كم هي مليئة بالنام عنوا 1 2 3 4 مثلا this is called glut 1 to 5 كواتل السرطان شو circulation but a transporter that's called GLUT 1 to 5. We have many types. We said 5 also is present. Some of them we say 6 and 7, but the most important one are these 4. Why? Because most of them are tissue specific, especially GLUT 2 and 4. We have glucose transporter number 1 that's present in most of the tissue, including brain and red blood cells. And the main function is that it will take basal uptake of glucose. Anyone knows what's the meaning of basal uptake of glucose? What is my name? Even if the patient or a person has in a state of hypoglycemia, low blood glucose, still GLUT 1 and affinity hemoglucose, still the glucose will enter into brain cells, will enter into the red blood cells. This is the meaning of basal uptake. Even حتى توقع الجلوكوز الشيء كان بين GLUT 1 باش يكون يحب الجلوكوز بدام بابو GLUT cell بتاعتي brain and red blood cell. GLUT number 2 or glucose transporter number 2 is specific to liver and pancreatic beta cells. The liver is uptake and release of glucose by liver. يعني شيء glucose كويش أكلي وأتوانر release جيكاتو. يعني do function bidirectional. GLUT 2 it will take glucose to the liver and also can release the glucose back to the circulation from the liver. Another way is only in the liver. When the pancreatic beta cells, it is a beta cell glucose sensor. ما بس تشيء يعني pancreatic شيء تشيء. ولا؟ pancreas das verstanden beta glucose sensor يعني شيء يعني هو بالسنسر يوان بس البنكرياس هو كجلوكوز برزة بيتوانه سنسر كات هذا جلوكوز برزة هذا شيء سكريشن كا انسولين سكريشن كا بو اوير ريجوليشن بلاد جلوكوز فهذا طبعا GLUT 2 لليفر هذا الشيء uptake and release of the glucose while in the pancreas it has a beta glucose sensor stimulate the secretion of the insulin in case of hyperglycemia or high blood glucose in the circulation. GLUT 3, similar to GLUT 1, is present in most of the tissue and also has a basal uptake. I have mentioned basal uptake مهمة. GLUT 1, GLUT 3, the زوربي tissue خانة. شو كزو مهمة كبasal uptake ما هي بوزورزو لخانة كانت. Vitality brain cells and RBC. GLUT 4 is present in skeletal muscle and adipose tissue or fat cells. It has insulin-dependent, insulin-stimulated glucose uptake stimulated by exercise in skeletal muscle. طبعا أنا مش معناها السكتر يعني أنا skeletal muscle كان. كاتيكاتو انسولين انشط اما سكرانيه نسوي مصل سوا باشا ام GLUT 4 هم نسوي مصل سوا انجا جلوكوز يعني انسولين يعني انسولين وايلي اكات جلوكوز بجلوت 4 شتنا وكيو شتنا مصل سوا يعني شتنا اديبوس تيشو يعني فات سوا اوكي حتى حوالي اكسرسايز شغله تو اكسرسايز اكي وهو انسولين بجابه تو شي بيت GLUT 4 كي زور تسر سيرسي مصل سوا هو جلوكوز ماشي شو تو مصلحي تو اكسرسايز اللي بعدها بيسبب انرجي زورترا لبرو مجبور لريت انسولين هناك هذا ريت او اذا تو الفور كي زور اللي تسمى ولا كو جلوكوز كي زور بخوي بقى بروك انرجي بتاعي باشا قاعد كاتي مصل كونتراكشن تو اكسرسايز كي بيسبب انرجي زورترا شلون الانرجي بس كي انسولين بدلنا ابيت باكسرسايز كان ستيميليتي او كان جلوكوز كاتش تسمى وولي سايو جلوكوز بقى بخوي انرجي بتاعي ويكتب الدوام بتواني اكسرسايز كي خلقي تبدأ كان مثلا contraction كي خلقي اوكي لم GLUT 1 to 4 كسر ساري هي تبيشن طيب GLUT 4 insulin dependent يعني dependent هذا سر انسولين يعني انسولين وايلي اكات كجلوكوز تتناول مصل سوا هاي اديبوز تيشو اما خوي dependent زي انسولين هذا اشتنا انسولين من الناجم ما عندنا حالة يقعد نبات كتو اكسرسايز اكي كاتو كتو مصل كونتراكشن هي مصل كتو شي سبازم بي كونتراكشن اكي لو كانت تشعر بالانسولين دلوقتي يعني شيء كان يقول فوركي السيرس في مصل سوا كان وجلوكوز السيركيوليشن بو بوشي ويبي قرر الانرجي تو بكاي بيني مو مصل كونتراكشن اوكي تيجي يعني تلقى انسولين ديبندنت GLUT is GLUT number 4 remember that okay. Let's go to the first pathway of the glucose metabolism, that's called glycolysis. Most of us hear about the glycolysis and how glycolysis starts and how it will end and what's the result. So as we know first, glycolysis is a cytoplasmic pathway, so you have to remember the area, the location that happens inside the cell, because we have many other pathways that happen in the mitochondria, some of them happen in mitochondria and cytoplasm. While glycolysis is a cytoplasmic pathway. It happens in the cytoplasm of the cell. It consists of 10 reactions. 3 of them are irreversible, so we cannot do a reversible step in these 3. It is irreversible step, but which is first step, a third, and 10 reaction. طبعا هي كم مسيهم وديهم أو يكباسي irreversible step لهم يمين كل glycolysis. السلام عليكم أخوي كزور معقد بكسيكين راح هو simplify كين clarification إنك شيء مهم هو. ويرجعني بيجرين رأيهم مثلاً شيء داخله وشون داخله وشون يتوه من شيء تعمل الله ويك مهمة أو أنا داخله. شدني توهمو سايكلو برودكتو همو بابا تكان همو لبري. باشا. So glucose will convert into 2-pyruvate. As I mean, resulting glycolysis here, yet more molecular glucose or 2-pyruvate or pyruvic acid. What's the aim? Is to release the energy in the form of ATP. So, if the cell has mitochondria and oxygen, glycolysis is aerobic. أشوف شو وقعته pyruvate أشوف إنه tricarboxylic acid cycle or bergamot or basi again. If either mitochondria or oxygen is lacking, glycolysis may occur anaerobically. هذا الشيء يبقى lactate or lactic acid use. So, such as erythrocyte, طبعا أو بيسمى mitochondria bergam anaerobic glycolysis معناها. وهذا exercise in skeletal muscle. أقدر أخلي exercise يزور كيت كان بريديني أكسجين يشبه أكسجين فيها أو ناكلت كهمو glycolysis أو بدأت أناو TCA بيها aerobic. Still part of each one of it, the exercising muscle, part of it anaerobic. شو الأكسجين كافي تنين بو away complete glycolysis أو بدأت أناو aerobic cycle. Okay? So still part of it in exercising muscle will continue anaerobically because whenever how much you breathe oxygen, it's not enough for exercising muscle. Especially أقدر تروح تيجي to exercising زور كي أو زور يعني هرشة aerobic cycle. بس ده بس كين كشون أقدر energy. Okay, so this is the cycle. You see it's very complicated and very difficult, but I'll try to make it easy for you. Okay, so we talked about glucose, how glucose will be generated, how we digest glucose, how we absorb glucose, okay? Now glucose in the circulation will enter into the cell, and once it enters the cell, it will see the first pathway which is called glycolysis. طبعا glycolysis كم enzyme كيبيننا يجيها hexokinase. This is the first step, and this is very important step. Hexokinase enzyme كان لهمو cell okay? And whenever you see a kinase suffix كتب لدواء بينيك particularly kinase area, remember that this enzyme will do phosphorylation of the substrate. يعني شيء يعني هكذا تكتب بينيك hexokinase, glucokinase, whenever it's kinase, meaning it will put a phosphate on its substrate and generate a phosphorylated product which is called glucose 6-phosphate. شيء أبعد هذا الكينيز ما بيني إنزيم الكينيز بيوهو شيء أبعد فوسفيت أخذ السل سبستريت أجي برودكت يدرس كذا فوسفوريليتر بقولنا إلى جلوكوز سبستريت أجي هكسوكينيز إيش يسمى جلوكوز كذا كذا شيء أي كذا جلوكوز 6-phosphate. أوكي؟ الفوسفيت اللي شو هاد؟ فوسفيت اللي ATP هاد ATP will convert to ATP. أدينوسين triphosphate كلمة بأدينوسين diphosphate phosphate المعنى. Glycolysis should be an energy-producing pathway. Yet, in the first step, we are consuming ATP and consuming energy. Why? What's the process of regeneration of the glucose 6-phosphate? Well, that's for sort of us. أنا مجموعة شنو يجوا high energy compound. مستقيم مجموعة كوزنا وتولى lecture كذا. But the main aim for generation of glucose 6-phosphate and consuming ATP in the first step of glycolysis. كبيريستا ATP ترسكات glucose 6-phosphate مستقيم بالامية energy كذا. What's your plan? In order to trap the glucose inside the cell. The very good man glucose. The glucose بيناتها يعني glucose بأسانية شكل ذرة وشكل no circulation. باشا بەڵام گلوکۆز 6 فۆسفێت هاي energy compound دروست دەکەین کە ناتوانێت بە ئاسانی لە سێڵەکەەوە بچێتە دەرەوە unless we have a special enzyme. ئەو باسی ئێنزایمەش دەکەین کە گلوکۆز 6 فۆسفێت ئەگەوەڕێتەوە گلوکۆز و ئێکاتە دەرەوە. بەڵام ئێمە نامانێت گلوکۆز بچێتە دەرەوە، معنی گلوکۆز لە سێڵەکە بمێنێتەوە in order for glycolysis to continue. Okay? کەواتە لە یەکەم enzyme, hexokinase, which is very important, that present in every cell, will convert glucose to glucose 6-phosphate by using a phosphate from the ATP. So we use or consume energy in the first step. Also, we have another enzyme that's similar to this one. It's hexokinase. This means it acts on the 6 carbon sugars. This is glucokinase that's specific for glucose. It's present in liver only. This glucokinase is hormone dependent. It will stimulate it by level of the insulin. As a banana say إما كاوتمان همو خانة كان مان كجلوكوز كيجرش للسيركيليشن أوا همو يأشت ناو خانة كان لو أنا أقول ساكن باشا جلوكوكاينيز بوشي باشا إما هيكسوكاينيز من باشا هيكسوكاينيز جلوكوز 6 فوسفات كي زوج دروسة خانة كميش إنرجي محدد بيستا هو نبدأ إنرجي بيستا إيماجن مش تيجي بس بقول مني أما نبدأ إنرجي بيستا ده إنتي بيستا لا ده إنتي بيكاي ده هو زيادة بيسني شيكات أم جلوكوز 6 فوسفات يقدروسة بيت أما هيكسوكاينيز تشيكا إنهبيتيكا هذا بس يتم جلوكوز 6 فوسفات بومبانيرا شو كمان إنرجي كامل الآن أوكي تيجي يعني جلوكوز 6 فوسفات أجل بشي سيلك enough bit تشيكا it will inhibit the hexokinase نبقى تاع hexokinase shut down a bit باشا إمنا هم جلوكوزام هي لنا circulation شيئا وشو ببعض أتشبه ليفر حليقة ما جي حليقة باب إنزيم الثلاثية هي ATP أو تري glucokinase. Which glucokinase حليقة؟ The glucokinase is not hormonally dependent, similar to hexokinase. It's hormonally dependent. It's unlike hexokinase. It is stimulated by insulin. Insulin is hormone in the circulation. A very hyperglycemic state. يعني glucose is hormone circulation. But insulin is رجال. Insulin is stimulating glucokinase glucose is sorted. Glucose 6 phosphate only in the liver. باشا بسيار أي liver is satisfying أبي liver شيء جيجنا وشيء تيجي بقى ولا storage أكتر glycogen storage ده liver ولا storage ده لأنه أول شيء أتواني كل اللي تفاصيل يشتغل عليه يعني أو جلوكوزا بويا هيك دعايتك عشان نشيل الكرب وشيش أو جلوكوزا كحياة أجل إكسترا بفرق شيء بفرق بفات أوكي كواتن لي فرقة أتواني بكاري بيني هم storage وجلوكوز وبلاتينوم glycogen يعني أتواني بيخاطر لبن باثوي فاتي بدوسكا أوكي لبيتي بدوسكا ترايجليسرايدي بدوسكا لبرو يا أن إنزيم تابع طبعا ليه ندرسه للليفر بوي كسر كان هم يساتسفايمون أو كاتب جلوكوكاينيز كريتش باش كيزورت الجلوكوزات أشتنا ليفر okay take it straight. Alright, this is the first step, and this is a very important step. This is a irreversible step. We cannot reverse it directly. A big enzyme you can reverse it step. This is called a glucose 6 phosphate. Again, I'm just saying that this is a reversible reaction. So glucose 6 phosphate will convert to fructose 6 phosphate, and then fructose 6 phosphate by the second important enzyme, which is the key enzyme in the glycolysis. Remember, this is a key enzyme in the glycolysis that's called a phosphofructokinase 1 will convert fructose 6-phosphate again to fructose 1,6-bisphosphate. You see, we have another kinase suffix here, so meaning it will add another phosphate onto fructose 6-phosphate and generating what's called a fructose 1,6-bisphosphate, meaning a bi. يعني 2-phosphate هي لسه هي بوشش يعني هي بوشش phosphate لسه بتشي باب انزيم كبي اوتر phosphofructokinase 1 again باب انزيم الجاي بيتر consuming ATP اللي شو فوسفات اللي هنا طبعا ATP كي بوري ب ATP وفوسفات كي لا ATP باش بوتشي الانزيم مهمة because it is highly regulated. Regulation is very important regarding this enzyme. How it will be regulated by level of AMP. AMP will turn on the phosphofructokinase 1 while ATP and citrate will turn off the phosphofructokinase 1. AMP cheer. Cheer, representing cheer. Yeah, of course. So AMP, the cell like a baseball, you need energy. Okay? And energy can show this here. Like, I'm going to slow this here. كواتم AMP چیه؟ Activating key glycolysis تبعك چیه؟ Phosphofructokinase 1 باشه؟ كابتو imagine كات exercise كات راحة كات رياضية ودور لما صلصلكان إنرجي كان بردوش كونسيوم شي بردو AMP بردو ATP كان بردو AMP بردو AMP بردو شيء كان stimulating phosphofructokinase هذا على خيره إنرجي تربومينه glycolysis active كان بوي إنرجي زيادة تربومينه muscle contraction okay in reverse when we have ATP when I get too much energy I'm resting state we don't need any energy anymore we will say turn off the key enzyme in glycolysis which is phosphofructokinase 1 in order to shut down glycolysis because I don't need energy anymore. Okay? Citrate tampons نکن با چی shut down میکنه. اولا السایکل کی ترش به اسمش سنسر نمیه. چون citrate shut down میکنه. Again, cycle TCA cycle. I will explain why citrate will shut down the PFK1. But just remember, the citrate will shut down PFK1. Look after every time you watch and Okay, so this is the second important enzyme. We said the first and third step is very important. Once fructose 1,6-bisphosphate is generated, it will split into what's called dihydroxyacetylphosphate and glyceraldehyde 3-phosphate. Dihydroxyacetylphosphate actually هو lipid metabolism يعني actually better over glyceraldehyde 3-phosphate. There همش multiply by 2. Everything will be multiplied by 2 from glyceraldehyde 3-phosphate downward. Okay? Glyceraldehyde 3-phosphate, we'll see, not important enzyme, that's why I didn't mention it, will convert into 1,3-bisphosphoglycerate. This is step that here generate NADH. And how was on the next step actually do step NADH do step. When NADH excited ATP, around 3 ATP. شلون أكيد ATP غير بلاستيكي. هل NADH هل molecule NADH تقريبا 6 ATP موجود مستقبل. Okay? So in this step, we will generate NADH, it's a high energy molecule, generate around 3 ATP. Then 1,3-bisphosphoglycerate will convert to 3-phosphoglycerate. What's important here is that this step is called a substrate level phosphorylation. We have 3 examples in our body about the substrate level phosphorylation. One of them is present here in the glycolysis. Anyone know what's the meaning of substrate level phosphorylation? Well, step back up. Now, so I'm going to substrate كامل. Substrate أنا واحد. Substrate أوي كده بيش إنزيم كده. Product كامل أوي كده دواء يدوس ده. أو أزان ثانية. باش. إذا substrate level phosphorylation. إيه شو هو ده؟ No. Anyone? Yeah, any idea? The substrate here is used to phosphorylate ADP back to ATP. there are 1,3-bisphosphoglycerate and substrate 2-phosphatidylserine. Result of the 3-phosphoglycerate. Productive create phosphatidylserine. Or phosphatidylserine is used to generate ATP. From ATP. That's why it's called a substrate level phosphorylation. The substrate itself is used to phosphorylate ATP back to ATP. So this is the first ATP that will be generated in this step that's called a substrate level phosphorylation. Let's say example and then 3-phosphoglycerate, we'll see not important enzyme, back to 2-phosphoglycerate again, reversible step, phosphoenol pyruvate. This is a high energy compound of the cell. It's even higher than ATP and PEP is very high energy compound. So I'm same enzyme pyruvate kinase. Pyruvate kinase. دوام ATP مواد مستقر ATP أقربه ATP چی مواد مستقر pyruvate مواد مستقر يعني pyruvic acid مواد مستقر. Okay, so this is the end product of the glycolysis. Both enzyme مهمة because not because of the regulation, because there's a disease related to the deficiency of the enzyme. Okay. By the way, we don't have a complete enzyme deficiency in the glycolysis. يعني أجل إن بيت يحيى الإنزيم كان glycolysis. Completely defective bit it is incompatible with life. يعني كسكنات يعني بشيء أصلا كسكنات من بيت الدنيا هو كالglycolysis enzyme complete enzyme defect معناته is incompatible with life. But we do have a partial enzyme defect like this. أجر defect معناته partial pyruvate kinase شيء وقعت is caused a hemolytic anemia. Okay? Anyone knows what's hemolytic anemia? Okay, في وصفة الأسئلة. Hemolysis يعني lysis of the RBC, lysis of the red blood cells. Hemolysis, okay? So this is the second most common cause of hemolytic anemia. Anyone knows what's the first or the most common cause of hemolytic anemia? Very good. G6PD deficiency that we will talk about is the most common cause of hemolytic anemia. The second one is this important enzyme that's called a pyruvate kinase deficiency. She used to be a deficiency man the pyruvate kinase. There will be hemolytic anemia. There will be increase a substance that's called a 2,3-BPG, is a 2,3-BPG here, which is bisphosphoglycerate, 2,3-bisphosphoglycerate, and there will be no Heinz bodies. طبعا no Heinz bodies شيء جاي أكاد ولا G6PD. G6PD the Heinz body جاي. Then على Heinz body شيء mechanism يدرسون نتيجة شلون G6PD. طبعا ده represent the pyruvate kinase. We don't have Heinz body. This is an important point. أنا رجعت microscope البيت. And now we're going to destruction of it. Again, Heinz body meaning is G6PD deficiency. If you don't see Heinz bodies, most likely is a pyruvate kinase deficiency. Okay? So this will be discussed later on. With hemolytic anemia, increase 2,3-BPG. زي compound here. To say that again, the pyruvate kinase deficiency again, excellent. Again, أنا بجواني إيش نقع. شيكو بتوا PEP. باشا PEP أما reversible cycle. دعائي شيكو بتوا 2-phosphoglycerate, back to 3-phosphoglycerate, back to 1,3-phosphoglycerate. Pathway one here extra RBC كان عليها. أما 3-phosphoglycerate but she is a 2,3-bisphosphoglycerate can 2,3-BPG. يعني if you have pyruvate kinase deficiency, all of these will go back and will result in elevation of 2,3-BPG. باشا 2,3-BPG شيء it will decrease the affinity of the RBC to the oxygen. يعني why the oxygen doesn't RBC decrease the affinity of the oxygen to the RBC. Okay? خوي بشر أبيها بدنا RBC كنا بويك كات RBC كنا circulation أو يتنا extremity كنا وانه oxygen كدeliver كات. But if it's too much, it will decrease the affinity of oxygen to the RBC. All right? That's why this enzyme is very important because there is a disease related to the partial deficiency of the pyruvate kinase. So once pyruvate is generated, if we have oxygen, it will continue in TCA cycle to generate more ATP. If we don't have oxygen, like in case of RBC or criticizing muscle, it will see the enzyme that's called lactate dehydrogenase will consume this NADH that was generated here back to NAD and will generate lactate. This is called an aerobic glycolysis, lactate or lactic acid. Okay? Percebem glycolysis. America was a تقريبا we said diagram So we said insulin-induced glucose uptake in several tissue, in particular muscle and adipose tissue. أنا بس رأيي أنا مش فاهمين بس كنا نقول هذا diagram. أو يقولون نقول أساس ما كتير In red blood cell, the first sign of ATP formation may be bypassed. هنا راسي بدرزبوني to 3-BPG like that. 1,3-bisphosphoglycerate is converted to what? 2,3-BPG or 2,3-bisphosphoglycerate. This 2,3-BPG combined to hemoglobin decreases its affinity for oxygen and making it available to tissue in some circumstances, for example, high altitude areas. طبعا لو area اللي كتبي يستفيد high altitude area كان هذا extremity كان كاتب دوام RBC تناو بنجا كان زيادة تناو extremity كان أقل لو اللي يستفيد 2,3-BPG هي وأويكا oxygen كجابة ولا RBC كود اللي فكر وسامك. But if we have too much oxygen, too much 2,3-BPG, the oxygen will dissociate from RBC sooner. I'm taking bashing. I have hemolysis. Again, أولاً شو أنا 2,3-BPG؟ طبيعي أبي habits. أبي 2,3-BPG بس شيء habit أنا RBC. فبوشي هو يكاتب كتوب oxygen circulation blood هات أنا extremity كانت باشا أو oxygen جابته بيها الصلاة كان برحالي بيت. But أجر زور بيت 2,3-BPG وكل حوالي pyruvate kinase deficiency, the oxygen will dissociate sooner from the RBC and cause hemolysis. Okay? So how we control glycolysis in homogascadone, hexokinase and glucokinase. We said phosphorylation of glucose is a very important step. One of you said because we want glucose to be trapped inside the cell, we don't want glucose to go out. So another reasons are make glucose anionic, increase the reactivity of sugar, and this will be ready for the next steps in the glycolysis, make high energy compound. Of course, whenever there's a phosphate on a compound, it is high energy compound. The second enzyme is PFK1, which is inhibited by, we said, negative mean inhibited by citrate and ATP. We talked about ATP, and we say we will postpone citrate to the next lectures. And we said that AMP will activate the PFK, positive mean stimulator. Hormonally in liver, we have insulin that stimulates glucagon, inhibit PFK1. اللي قاعد جوازا شلون هو بس الجلوكوكاينيز معناها الانسولين stimulator but how PFK1 is hormonally regulated, stimulated by insulin and inhibited by glucagon. Glucagon chia counter-regulatory hormone or insulin. Right, but actually insulin هو الشغال. Okay? Insulin شلون لوريني blood glucose glucagon increasing blood glucose. Right, but actually insulin. That's why anything that inhibited by or stimulated by insulin will be inhibited by glucagon. Which one lactate can do stability? Lactate can do stability if you have anaerobic pathway. If you don't have oxygen or mitochondria. Lactate do is which one glucose and pyruvate. Pyruvate is the LDH or the lactate dehydrogenase. You can see me in DH kind of cheap. lactate. باش أنا lactate من شيء يبقى. طبعا يكشف هي لكاتي exercise أنا بدي قدبا دعاء exercise اللي هو فترة كمية تشي شيء تشي exertionally. Pozio exercitia am lactate, oggi lactate tosti bebi la masla canta, away built up lactate hizodus. أو lactate acidic. وهو اللي شبت حسب exercitia, حسب لactate شكلتي. أوكي؟ طبعا باش تقول سيكي أو lactate ونعمل exercise كبو، شو lactate حلبت، شو حلبت بالشوارع. lactate كالسيركوليشن هذا LDH بحدو ديو كي إشكا يعني pyruvate أتواني بورا lactate بالمقابل lactate كش بورا pyruvate, okay? كاتل LDH بحدو pathway إيشكا أتواني pyruvate بورا lactate و lactate back to the pyruvate. كاتل we have too much lactate in our circulation, for example, after exercise, it will see this LDH enzyme again will generate the pyruvate. Pyruvate which is getting especially the liver and heart muscles, will generate glucose in a pathway that's called, this is an inhibitory pathway, the pyruvate with the glucose. Gluconeogenesis, very good. It should generate the glucose by the liver. This pathway is called gluconeogenesis. يعني تستنوي glucose جاري بيتر وهو الليفر. Okay, كاتل لنا pyruvate ده ويبقى أكسيجلان توصل شيء كده. glucose يدوس كده. يلا هارد مثلا كان أتمنى CO2 دوس كابوش يشوف أشد TCA cycle. CO2 دوس كا ATP زيادة دوس كا. Okay, pyruvate ده كاتل شد aerobic cycle. أشد أنها TCA cycle CO2 ATP دوس. Okay, boş şeyler değil hareket. Yani çete liver, yani çete nasıl yapar? Okay. Cosa can lactic acidosis share with lactate? Increased production, of course, whenever they have increased production, like in case of exercise, last month I got to realize lactate kizor built up in chuka. Hatchel oxygen breathing case, still part of your muscle will go into anaerobic glycolysis. Still there will be lactic acidosis. There will be increased production of lactate. Okay? And then we have shock and congestive heart disease. What's your shock or congestive heart disease? Of course, yeah, in case of shock, in case of heart failure, there will be decreased the oxygen level. So whenever you have decreased oxygen level, the glycolysis will go anaerobically and will generate more lactate. That's called a lactic acidosis. Or we have decreased utilization. That's why in when we have liver disease, we cannot convert lactate back to the pyruvate and generate glucose because we have liver disease. The liver has a problem. Or we have a thiamine deficiency that we will talk about in case of alcoholism or others. We will talk about how the thiamine deficiency will cause decreased utilization. during alcohol metabolism, these are similar. So we will talk about the mechanism, how they will cause lactic acidosis. We start on there. These are the references.